Hey guys, welcome back, Carter. BitsBeTrippin. This is part 7. So we're doing the follow-up to the Simplemining build setup. We did a gaming computer with this right before. Walked you guys through a semi-long video on some of the configurations, adding a miner, all that kind of stuff. You want to check out that video if you want to see on how to add a miner. That's the video for this. So that's the video that you want to see for that. This video is going to be what's it look like from a rig perspective, like putting, a case like this together, or purchasing a mining rig like this, getting a motherboard, a power supply, and then having the ability to expand to multiple cards. So we have a couple cards in here right now. We have an RX 570, 16 gigs. So this is the Sapphire kind of mining edition card they came out with. Very specific card that Sapphire built, which has 16 gigs of RAM on it. That's a lot. Like in this series, these are Polaris cards. They usually only had 4 gigs or 8 gigs. So this is like a kind of a unique card. Doesn't really help it mine. It just has a ton of memory on it. And then an RX 590, I should say, RX 590 GPU, which is the latest edition of the Polaris line AMD cards. And then they went on to the newer architecture that we were just kind of playing with, which is RDNA tech here. And it looks like we're having some battery issues here in this laptop. So, all right, guys, we are back. Let's get into this. So this GPU mining rig setup has an ASRock H110 Pro BTC motherboard. That is a 13 GPU motherboard. We'll throw some close-up shots of this for you guys can see it. This was a kind of a rare bird. It came out for just a very short period of time, right when mining was kind of at its peak in 2017 and into 2018, and then it kind of had a dive on the GPU mining scene for a little bit. So these were kind of short-term boards. They had their issues. The primary issue is you can see how close those are, right? So part of the issue is when you have the risers so close to each other, you would actually have them touch, the metal pieces touch, and sometimes they would short out. So a lot of the implementations of this board, what I would tell people is, put like electrical tape around the ends to where they were really close like that. And then as long as you could separate all of them, if you were using this board for a full setup, you'd want to separate all those, so those risers to each other. So if you do find this board out in the wild and you find a good deal on it, and maybe somebody said, hey, it wasn't really consistent for me, or it didn't work out for me, and here I'm selling to you cheap, I'm betting that was the problem, because otherwise these boards are rock solid. Like they're really good. If they post, which means they power up and you can see like a ASRock when it's booting and stuff, right, this board's good. The problem that people were having is that the risers were too close and they were shorting out, and that's why it was inconsistent for them. So that I just wanted to open with that. If you're going with a board like that has all those slots really close to each other. In this particular case, we have a couple GPUs here, and we're going to show you guys kind of the setup with mining rig, where you could add more cards and you would see them as they would come into your Simplemining here. So let's switch over to what the Simplemining screen looks like right now. We have it running right now, etc. That is the main machine right now running. You can see it running Simplemining and running LOL miner. And we can pivot over to the laptop to show the dashboard. And you're now looking at the dashboard and with the settings that we're running on these cards right now. And we're going to play with the settings a little bit here. So you can see the two cards that I was talking about, the RX 570, and this is the 16 gig GPU, and the RX 590 8 gig GPU. Now it's giving you the micron, memory type and all that. There was a point in time where that mattered a lot. It doesn't matter that much anymore. And that was where we had that discussion a few episodes ago about putting a BIOS on the card, and it was memory amount and memory type centric. So that's why you'll see a lot more telemetry of like, why is it giving me like it's GDDR5 micron memory, 8 gig memory? Like that mattered when you were updating a BIOS. Now most of the miners have all of these settings already pre-set up for these cards, so it it pulls that data anyways and then gives you the best, memory strap settings possible. Now, on the side over here, we have not named the rig. We're going to name this what do we call this, like silver rig. That way we could just know about it here. And then the settings we have right now are 1200 to the core clock. Okay, so we're bringing this cards down. These cards run around 1560 to 1600 total core clock stock. We're bringing them down. And then we're bumping the memory. These cards both have memory speeds that are starting at 2000. And you did bring up an earlier question. We were kind of setting these up where we were counting half of the memory speed in Linux with the Polaris cards, this type of architecture, which is the RX 470, 480, 570, 580. So it's 4th generation, 5th generation, and then the 70 and 80s are just different chips on them.
Right.
Each of those have either 4 or 8 gigs, with the exception being the 570 had this weird variant that had 16 gigs optional on the Sapphire cards. Typically the 470s memory started at 1750 megahertz, and you could take it up to 2000. All the 8 gig cards had a memory base speed of 2000, and you can take those up to around 2200. We're at 2100 right now, and we have undervolted the core. The core has like a base core that's millivolts, so it's about 1.1 volt card. We're taking it down into 0.89. So instead of 1.1, it's 0.89. So we brought it down some. Now we could try 0.50, usually, or 0.850. Anything under that, I mean, like the other card, the 6600 we were just on, we had at 760.
Yeah.
So it's millivolt. It could run lower on the core because the architecture didn't need to have as much juice going to it. On the Polaris cards, like the 570s, the 470s, the 480s, 580s, 590s, like 850. Sometimes I've seen them run as low as 830. Like any more than that, it's probably gonna lock the machine up. Like it just says, nope, sorry, I don't exist anymore. You just starved me too much. So again, like all of these things is all about playing a game. How low can I go on feeding it electricity and still get close to the same upper bound of the results that I want? So like on these cards, the upper bound on these cards are about 32 mega hash. That's like this series' top that it could get. So if you can get around 30 mega hash, like right now we're at 28, 29 mega hash, with a very low voltage, you're doing good. The card's not running hot. You're not using up as much electricity. You can see here we're using about 89 to the main part of the card. The riser's using a little bit. It uses about 20 watts there. So these cards are about 105 to 99 watts each, which that plus the system board is why we're setting at like 300 watts total in the system right now. This says that the whole system should be running about 306. We're running about 312 over there on the main meter. So it's pretty close to the whole system voltage. So it's taking those two cards plus what we have as the system aggregate on that. So we're going to try to just bump these to 20. Let's do 2150. So we do, no, that might cause some issues. 2500. All right, 2150. We'll keep that at 830 there. We'll scroll down and we'll hit save. And we're going to push those settings to that. We'll see this update and see if we can get those cards a little more. I'm just trying to make sure that folks know how. And you can see now it's showing, hey, it pushed 1200 plus 2150 memory. And now it's going to start to try to run those cards a little more. And let's just see what we can get it up to. So it's going to start spinning up. And again, the hash rate is in millions of hashes per second. A hash is like this string of alphanumerics. This is doing that in millions of those per second, right? So it's just a huge amount of data, or a huge amount of processing speed, not a huge amount of online data like the network. There isn't a lot of network bandwidth used when mining at all. Like it's kilobits of data not even huge amounts of megabits or anything. So like if people are ever curious, like, do I need a fast internet connection? Any of that kind of stuff? You don't. Like people literally do entire containers of hardware, like an entire like container ship size, 53-foot container, 12-foot tall, filled with rigs, and they'll be on a single LTE connection, like phone connection, because they're disconnected. They maybe have like some kind of solar setup or some other local substation for power, and they have no line access to internet. So we're seeing what this thing will do. We're seeing the one at 20. So I think we killed the one card. So at 2150, the hash rate of that one dropped completely off. It is not stable at 2150. So this card here is no longer running. See how it's setting at 0?
Right.
And it says 0 here, and the other one's at 29.5. So in this particular case, we're like, okay, so the very first card, we'll put a comma there. So we're going to go, let's try to run that card at 2000, comma, space, and see how it's rebooting that miner because it knew that it died. So we're going to save. And now this machine is going to reboot itself because it killed the card. And that's what I was saying, that what would happen is if we went too much, it's just not going to work. It's just going to say, yeah, sorry, can't do it. It was a cool story, bro, but we were unable to make it happen. So the machine's rebooting. I've saved these new settings. And what this is it's GPU 1 and GPU 2, or GPU 0, GPU 1. So you can actually separate these based with a comma.
Okay.
So the first one is going to go to that first card. And we're going to say that's going to run 2000 because it just doesn't work. The second card's going to run 2150 because that seemed to be stable on 2150. And then both of them are going to run the 1200 core. Now you can individually set these. So like if you had 12 different cards on this particular motherboard, or 13, you could have commas between them all. And that's why like we're right now using two completely different, I mean, they're Polaris architecture, but this is a 570 and this is a 590. So they're just different cards in general.
Yeah.
So in here, you can see GPU 0 is using 1200 1200 with 2000. GPU 1 is using 2000 with 2150. So now we'll see if those set and everything works when it goes to start mining. And sometimes it will do this too, where it'll just freeze. It's just like, yeah, I'm still not cool with whatever those settings are. Right. And when that happens, I usually just change it again. So I'll try 50. Let's try 2050 there. Let's try 2025 here. Let's take this down to 1120. Let's try to pull some more. We're changing a lot of settings. Now, some people have different opinions of the way they'll do it. They'll make one change to one thing and then try it just to see if it's stable. Yeah. I used to do that. It's kind of the observe and report, try to lessen your variables type of thing. But over time, as I started to understand the behavior of the way GPUs and stuff work with this stuff, I changed my behavior to go just to what's my main target based on experience. And because I would say at least 8 times out of 10, most people say 9 times out of 10, 8 times out of 10, about 80% of the time, it just works, right?
Yeah.
With the settings I put in there. And then I'm like, okay, that's good. And then I may make one little tweak here and there to then try to balance out what I want to do. So I go kind of for a target of what I think can happen. And there's different, it's just not taking a shot at, well, I'd love everything to run at 3000 megahertz. You don't do that. You know what the upper bound and the, what they call the range is, right, by just researching from other people that have tried things. And they say, hey, I have this Sapphire card, and that Sapphire card runs really well at this based on all the hours I put into it. And they're being a bro and putting it out there for you. So one of the very first steps you go out, you would look up the model of this card, space Ethereum mining, and Google that. And then you'll get a whole bunch of hits. You'll find Reddit. You'll find just people making comments. You might find a video. and then you'll get a baseline of what the card does. 90% of the people that hit this video through the search piece does that naturally by just finding us and then they're just looking for, they don't care about all the stuff we're talking about right now.
Right.
They're literally just looking for that setting. Right. So, just going out there and saying what works, or making a post of like, if you find something that's really good, like, you're being a bro to go out there and tell everybody,
yeah,
like, hey, let me know what worked out. And it's betterment for the community, and it generates a good community, right? Because then you're able to find things that you want to find, and then when you've successfully, other people can find things that they want to find, right? So you notice how I changed the settings. I restarted the machine. Yeah. I physically restarted the machine, not just I powered it off, powered it back on. Sometimes it'll do like a hard reboot, or what I call a soft reboot, which is where the machine just stayed up. It never lost power. It just rebooted the OS.
Yeah.
And it didn't recover. Sometimes you have to do a hard reboot, which is where you're holding down the power and you're just hard rebooting it, which just literally sets it down. And right now it's doing its optimization. So we're going to see what this goes up to. So now this one's at 28 and that one's at 28. That's at 2050 memory. We'll see what they're good at here. And we can try a different miner with this too. So this is LOL miner. We can try these same settings with the Team Red miner and see if we get a better result. And that's the other piece that we'll end up trying to with that. So it looks like about 28.3. I mean, the Ethereum stabilizes pretty quick. So like once it's kind of found its settings, it'll lock in, and then that's what it is. Yeah. It won't usually gyrate too much. It's not like Ethereum or like a Kapow, which is Ravencoin's out, which has kind of some oscillation to it. And this old algorithm that it had before that was X16R. It literally went through a range of 16 different algorithms, and it was every time it went through like a cycle, it would re-randomize those 16 in a different order, and some were faster than the other.
Right.
So sometimes it would like drop a lot because it was working on a harder solution, and then it would super fast, and then it gave you this very range. It was very hard to tell people like what the output of a card is.
Right.
Like we do this and we say, hey, you know what, with these settings, the best we could do is 28. Sucks we couldn't get 30 whatever out of it, but it's 28. Well, with the Raven, it's like, with the old Raven, I was like, your range is 5.6 to 11. Like, sorry. And you had to observe that over a longer period of time. And somehow, not a lot of algorithms do that anymore. The X16R ended up being taken over by an FPGA, which is a programmable version of this, where you can write specific software to be more optimized around it. And it's kind of the middle point of a graphics card to an ASIC, which is just completely hardware designed to do the task. It's kind of sits in the middle of the stack. And a typical FPGA, which is only for a few algorithms out there now, is like $5,000. They go from like $3,500 to $5,000 for the piece of hardware, because by design it was designed for you to make some kind of special software that would work with that hardware. So I think we're where we're at on that particular thing. Let's take a real quick one and just change this one to the Team Red miner. And this is a good test anyways, because we were getting all those rejects on the Team Red miner earlier.
Right.
So let's see if we still get rejects. And that could be our configuration. We'll confirm it right here, because this is it's working well with LOL. If we start getting rejects with Team Red miner, then our configuration may be off. Not the settings. It might be just the configuration we have on
Team Red miner.
Yeah, I'm going to go into these actions and clear counters and come back up, because that's just how many times it's rebooted and stuff. So here's Team Red miner running. And now this one does this kind of auto where it's doing it will run like a check to see what's the best memory injection that it can use. And that's the thing that's taken place of having to replace the BIOSes. So it's doing kind of an optimization to figure out what's what's the best one to use.
Yeah.
And that takes a second. So we're going to let this, when they spin up, it takes a little bit. It takes a reading like it just did right now. And it's only like 7, but it's going to come back and yeah. So see, this gave us a rejected. So something up with this is wrong. So our settings on this configuration for Team Red Miner are incorrect. So what we're going to do is we're going to go back to Ethermine, and we are going to get off of the SSL. Start mining. We're going to use this one. Make sure that is correct. And we're going to go back into the group config. We're going to edit this. And we're going to just get rid of, so that's all right. So we're going to get rid of the SSL piece here. SSL, and we're going to switch this to not 555. It's 4444. So it's all 4s. Four. So it's stratum, and then we need to do plus TCP. Plus, oh, not that one.
Wrong. There's keyboard.
Right? Yeah, that keyboard. Wrong keyboard. Too many. I get literally 3 keyboards in front of me. TCP. So stratum plus TCP, because that's the other part of the protocol that we need to save. Save and reboot. And then now we can go back to rig list here, and we're going to see it push those settings and come back. Here we go. And for whatever reason, if this ends up working and we get good shares, then something with that SSL was messed up.
Okay.
And that's what I said on the other one that we had, is that sometimes the SSL port maybe not be sending the right correct proof of work. It might be on the it's not on the wrong chain. It's just that their node that's creating the jobs, the work payloads for us, might be just given an incorrect job ID. It might be something wrong in their SSL config. Things happen when it comes down to secure socket layer. There's what they call certificate key chaining, which is like when you go to a website and you have a certificate, like, and it says that this certificate is valid and all that. That it's an issuing authority that does that. Sometimes they can have like something wrong with that, or the cron job, which is a job that runs on their Linux server to like create those payloads for us, could be set up wrong too. I mean, there's just things that could happen in the configuration where it looks like you're connecting, you are, but the work that we're getting is incorrect. So everything that we were submitting, well, it looks like we're still getting rejects here from Ethermine. And that could be just something up with, I don't know, Team Red's just giving us rejects here, because I mean we were successfully running fine there, but the other thing that this could be is that the address that we've given it is incorrect. Like the etc address that we have in there. So what we can quickly do, Exodus. Let's just validate a good address. So this is a fresh new wallet. It will remind me later. For right now, for this, we'll go here. There's no money in this wallet because this was a test wallet. Ethereum Classic. Let's just validate to a new address here. So here, because it could be incorrect address here. So yeah, we're gonna group. So you're telling me, my dude. Team Red Miner. Is that before or after the here? And then let's paste that. Let's save it. So we know that that's a good address because we just opened up a wallet.
Right.
And we're trying to change it right now. Yeah. So now we're going to go back to root list. We're seeing it here. And again, we're trying to get it back to where we're not getting rejected shares with this. That's the whole point of this.
So if that doesn't work, what do you think it's going to be? Just that.
So if that doesn't work, I mean, it would make me wonder if something's wrong with either Team Red Miner. I don't think it is. I mean, sometimes I would try a different version of it. Like I would just click it down one version to see.
Because that was the newest version, right?
That's the latest version of it. Because this is like two different pieces. This is two different architectures that we're trying it with.
Right.
We're getting a response. Yeah, so we're still getting an error there with that US-1 ether mine. Receive new job. The share was rejected. Error code 0. Provided a solution that is invalid. So yeah, something else might be misconfigured on this. I mean, I've seen this also happen when the motherboard has the incorrect time on it. Like this had like the BIOS reset and like it thinks it's like 1990.
Yeah.
And sometimes the part of its validation check is like you'll see this in other things, like if you have a wrong time on the machine itself, like it doesn't know how to handle the certificates correctly. But yeah, we're having again still another issue with this Team Red Miner having an issue. What I'm going to try real quick is we're going to just switch this over to Ravencoin real quick and just see if we have any of there. Because I think the Ravencoin, do we have it on this? What we're going to do is go back to here. We're going to get rid of this one. We're going to go back to here. Actions. Wait a minute. This also could be, wait a minute, it might be even more simpler than that. If we go back to group config, are we set to the right? Nope. We're set to the wrong. That is my bad. So this is the last thing, and I'm glad that we were able to find this. So right now we are set to Eth hash, which is ETH.
Yeah.
We need to be on ETC. This is the other thing, ETC cache.
So you're trying to mine.
I'm trying. So I'm getting the wrong. Yeah, I'm getting the wrong thing here. So this is the other thing. So the other stuff I was talking about, why it's still valid on giving you errors in some sort, it was a lot simpler than that. It was literally we were mining Eth hash instead of classic. So
you take full responsibility.
I do take full responsibility of that, my dudes. So we're going to go right back into here. And now we're going to give it a reboot, a good reboot. So let's do a shutdown of this. So you see this?
Yeah.
So what that means is we were running too high of a thing on that, and we're getting a memory fault on this. So a GPU problem detected here, but it was because it was showing a crash here. But this picked up that there was a problem here. So after the constant reboots like that, we're probably running the card on its very tippy top of edge because we're getting artifacts on the screen. Whenever you get artifacts on the screen, because this is plugged into this card. So we know that if we're pushing it too hard, it's going to give us some artifacts on that screen. That's what all those little boxes and stuff were. So the 21, 25 memory may be too much, or the core clock and the voltage is too low. And it's just the card can't handle it. So those again are also things that would cause, something crashing.
Right.
So I mean, again, it's all as like our recap. Like we're playing with just a few settings. We're playing with the memory speed and the core speed, and we're playing with the power settings. any one of those things that are just out of the tolerance of the individual card can cause a range of issues. This is why a lot of people are like, bro, like GPU mining is such a pain. But it is very fruitful, like on the chance of, you know, the revenue piece of it and just being able to speculative mine new coins that came out when they first come out as proof of work because you use a GPU to do it. And, you know, they may not add it to a, you know, they may not add a, these coins to an exchange, so you can't even buy them. So the only way you get them is mining them. So that's part of the thing of like understanding this pretty implicitly. That once you kind of understand the upper bounds of both sides of it, you can play around for optimization, but you can set it to kind of in the middle. That's pretty good, and just get that and move on. You know, it's all about time management of how much time do you want to invest into your investment. You know, to try to milk as much as you can out of the card in the most efficient way. So now we're getting this job. We're again trying to make sure that we should not get any more errors here on rejects, because now we are mining to the correct algorithm. See, this is going to trigger a lot of people that didn't get to this part of the video.
Right.
Because I'm like, bro, I see it on the screen. I see that you're going to the wrong network. And they have to wait a whole other video to get to this one.
That's pretty funny.
Right? Because yesterday's video, they were like, no, I know what the problem was. And it's going to be in the comments. And I'm going to be like, just wait for tomorrow's video. We find it. This is pretty good. So yeah, we're up to 28, 29 mega hash. And you can see these tuning. It's telling us that hey, this is using A206 config, and this one's using A226. Those are just like database entries with settings. Yeah. So it did some testing and said, hey, those are the best versions of the memory straps that I'm going to use on these particular cards. And that's why we're sitting here almost at 30 a piece. We're at 53 mega hash. Have we sent a successful job? We have. So we got an accept.
So now you can go back to that website, right?
With this address here. So the address I took out was probably right.
Yeah.
Which is fine. We'll just check this address real quick. Paste. And yeah, we're already seeing reported. We're seeing a gaming rig, which this is actually, we didn't update the name of it. But now this is telling us, this is the pool saying, hey, on this address, I'm seeing some shares being submitted. You're reporting to me that you're averaging 50. Right now, I'm not reporting a current hash rate because I need some more shares to calculate. Because they don't actually know what your actual hash rate is. They have no idea. We're reporting, like they can read part of the miner to say it's reporting at 50, but somebody could falsify that, right? Somebody could say, I'm doing 500, bro. What matters, the way they calculate it, and this is a big point to people that miss the point of like mining pools and how things work. Let's go to the screen while we're waiting for this thing to go. So mining pools have no way to know what the real hash rate is, but they do know the size of the work that they're given to you. And they can run an algorithm to figure out, like, if you're submitting jobs to me this often, this quick, with this much complexity of work, then I'm calculating you to have this much hash rate for you to be able to solve solutions like that. And a normal question is, well, can I change the difficulty of the work packages? You can. A lot of these allow you to make them larger or smaller. What you want, and most things are set to auto, because what happens is if you have too big of a workload, you'll be working on it so long that they'll move on a block and you'll get a rejected share, because it's like, I finished this big complex thing. It took me, 30 seconds. And it's like, well, Ethereum's block time is every 15 seconds, bro. We were 2 blocks past you. So you want quick workloads that you can finish and submit. And it's a balance of, but you don't want them too quick, because then you're almost DDoSing which is like doing a denial of service attack on their stuff. So it's a balance, and a lot of them are auto now. Back in the day, you would have to figure out, am I a big mining farm, or is this a lot of hash rate? Is it multiple cards? And you are setting essentially your difficulty setting, and then you were, bottom line, what happened is it would just, you would see a lot more rejects, what they call stealth shares. Just because they're like, hey, we're already past this. So I wanted to give everybody that context when it comes to like the mining pool side of it. But let's switch back real quick and let's see how we're doing, and then we can wrap this video up because we're at like 30 minutes already. Laptop. Good job. All right, so we'll refresh this real quick and see, is it picking up? It is picking up the worker, and it still hasn't picked up our hash rate yet. This takes like 5 to 10 minutes to really kind of start giving us something. We can see down here that we've already submitted 4 shares of work, right? So it's if we let this go for a while, it would actually end up having a pretty a decent payout for this much hash rate. We can actually go out there and calculate that. Remember, we were talking about like, well, what's this thing output? We're looking at 300 watts on the dot right now. We're at 297, 302. So let's call it 300 watts. Let's go to type here. You can type ETC hash rate, our mining calculator. There we go. Google's listening to me. And we can just go, crypto compare is fine. So we're going to say we're at 58. Was that 58 hash rate? 57.63. 57.63 averaging. Let's call it 297 watts for this whole system. And we are 8 cents per kilowatt here, 0.8. So this machine on ETC, it will take it a week to mine a third of an ETC. Okay.
Yep.
Which is about $17 in relative profit, right? It's $3 for power for this thing to run for that week at our cost rate. For a month, it would get 1.43 ETC. Right, that's if we were just mining Ethereum Classic at $17 power cost to run this, and it'd be $74. And then if everything was flat, the year is pointless because the networks just change over time. It can actually get better. Sometimes the network hash rates go down, and we get a better return. So we can do the same thing with Ravencoin. So if we switch this real quick to Ravencoin, just to get a spot check real quick, and we're not going to set on it too much. If we go to here and we just do actions, we do group config, and let's do Ravencoin and save. And then we'll go right back into this. We'll watch this start to spin up on Ravencoin. We'll get the Ravencoin hash rate of these. It should, spoiler alert, it should be like 12 a piece, 13 a piece. So it's probably 26 mega hash. And it'll be probably 200 or 350 watts. We're seeing this go up. Let's just put those numbers in right now just to give us a little bit of jump on time. Back. Let's Google. Try it. Let's do Ravencoin mining calculator. So if this is, let's just say it's 24, we're going to check it in a second. And I'm looking at the power right now. It shows 370 right now. 370. And we're at 0.08. Calculate. So 24 hours, 25 Ravencoin, $3.71. 7 days a week, 177 Raven, about $25. So that other one was 17.
Yeah.
Ravencoin's even a lot more profitable than Ethereum Classic right now. $5 cost. For 30 days, 660 Raven, it'd be about $90 versus 71 on Ethereum Classic. So you see that even Ethereum Classic, or even these were better. We're off of this now, but it started to calculate there. So yeah, we're actually 27.97. I'm eating my own words. So we're at a total of 28.3. That's just the average coming up because it's getting 14. Yeah, 590 doing some serious work. It's like the 16 or the 6600 XT speeds. Let's go back here. So this is actually 28, and it's still 370 watts. Calculate. So a little more. So 206 versus 166, 770, $105 a month on 2 GPUs in Ravencoin, which is 770 Ravencoin. And it comes back down to ultimately a long-term discussion. So if we're talking something like 770 Ravencoin, 2 GPUs, 2 older Polaris cards, this thing's costing you, $21 a month to run. And if Ravencoin goes through its halving in January and goes to $1, then that would have been like, you're not earning just, $105. You're earning $770 per month on 2 GPUs. And this is where, when people try to understand like GPU mining, and I go, well, back in the day, I used to mine, 3 or 4 Litecoin a day. I used to mine, 120 Ethereum a month on, a handful of GPUs. And now Ethereum is worth 40, it went up to 4,300 in May. It's 3,100 right now. This is what we're talking about. This is why people mine. Like, people are like, I don't get it for the scraps that it seems like we're mining for.
Right.
770 Ravencoin right now at 14 cents. Yeah, it doesn't seem like a lot. 770, if this in 5 years goes to $2-3, well, that was 3,500 a day on 2 GPUs. Not saying it's going to do that. Ravencoin could stay the same price forever. It could slide back down. We don't know. That happened to me with like Feathercoin. It happened with me with VTC, which is Vertcoin. There was a few coins that I speculatively mined, held up their networks, and then they just never really materialized. The communities kind of fell away. Things happen. So it really comes down to community. It comes down to building. It comes down to giving the network a value of some other thing other than mining. We are just upholding the network, and we're compensated in a token for doing that. That token happens to be worth money. So, we're a service provider to help these developers have a network to build on. So that's my kind of PSA at the end of this for today. I can tell from just as you're, repeating some of the stuff, I think you're starting to pick it up.
Yeah, for sure.
You think you're getting close to where you think you put a rig together? We'll start doing some of the hardware stuff.
Yeah.
Awesome. Well, we're working on trying to get a couple more of the 6600 XTs, and we'll put a full rig together for you guys. And Ray will be doing that build. So thanks again for hanging out. This one was a little longer than normal, but I think it's still good content in this newbie series for you guys to have reinforcement around some of these basic principles. So again, like, subscribe. Let's try to get to 100K and share this with your friends, my dudes. Peace.
Peace.
There it is. Wrong
Wrong keyboard.